All right, I think we're probably good to get started here. Morning, everybody. Thank you for joining us. We're our webinar series on continuing education for our PEO credits. I want to introduce Ronnie from Neptronic. He's going to be talking to us today about humidification of critical environments. If you have any questions, feel free to put them in the chat as we go through. We're going to try and hold off on them until the end, where we have a question period. But if something is very critical and applicable to what we're talking about right in that moment, I'll pull it up and I'll ask it. So I won't talk your ear off. I'll hand this over to Ronnie. Ronnie, if you want to get started and introduce yourself and take it away.
Perfect. Thank you, Cam. Thank you, everyone, for being here today. So as Cam said, my name is Ronnie. I'm from Neptronic. I have a background in mechanical engineering. I'm a mechanical engineer, and I've been working in this field, mostly the humidification industry, for the last 17 years. And it's been 3 years now. I'm working for Neptronic. So for anyone on this call that never heard of us, Neptronic, we are a manufacturing company in Montreal. We've been established since 1976, and every product we manufacture and we ship is manufactured at our facility in Montreal, in Quebec. So we're about 400 employees up to date, and we have a couple different products, not only humidification. We do also electric duct heaters, actuators, valves, and HVAC controls. So we have 5 separate sections at Neptronic. So today, as Cam said, we'll be talking about humidification. The agenda mostly will be the importance of humidity, why we need to humidify, what we need to consider when designing humidification job, what type of products exist on the market, and each product, what's its pros and cons, and for each application, which product makes the most sense. So as Cam said, if you have any question, please feel free to tap it in the chat, and we'll go through all your questions at the end of the presentation. So I'll start from the beginning. So why we need to humidify? Why people talk about humidification? So if you look at the typical humidity chart, humidity will not change much. During summer, winter, you'll always be between 50 to 80%. What really affects the idea of having to humidify in winter is the temperature itself. Because if you look at the temperature, that's where you have big fluctuation happening between summer and winter. So if you take a bubble of air in winter at 30 Fahrenheit, even if it has 80% relative humidity, once you heat this bubble of air to 70 Fahrenheit, indoor conditions, now you only have 18%. Because warm air can contain much more moisture than cold air. So when you warm your air, the bubble of your air can retain much more moisture, and that's where the reason why we need to humidify, mostly in winter. So what type of application do we use humidity? Any type of application, we should be using some sort of humidity level. So if you look at museum and libraries, you need to maintain a certain level of humidity to be able to conserve the arts, to conserve the books, to conserve, any piece of art inside the gallery. Office, hotels, and schools. You need humidity for the indoor air quality, for the comfort of the people inside these buildings, and to mitigate, the viruses. And I'll explain a couple slides how you mitigate viruses. Until COVID, no one really cared about having humidification in schools and offices because, indoor air quality was not very important. But now everyone is trying to push towards indoor air quality as well. So data centers, clean rooms, you always need certain level of humidity so you don't have electrostatics on your servers. Pharmaceutical lab, you need to humidify. Hospitals, surgery rooms, printing industry, tobacco industry, food industry, any type of industry, you need certain level of humidity. So if you look at this chart, that's called the Sterling chart. It was released in 2008. It shows the optimum zone where you should be always when designing a job. You should always be between 30 to 60%. So if you go below 30, you'll have problem developing bacteria and viruses and infections. If you go higher than 60, you'll have different problems, kind of fungi, mites, allergies, and chemical interactions. But this chart was good until COVID. When COVID started, a lot of studies were done to try to understand the effect of the indoor air quality on the virus itself. And one particular person called Dr. Stephanie Taylor, she's a Harvard med doctor, and she did a lot of studies on the importance of humidity related to the virus. And to summarize that in just 1 or 2 slides, what she ended up finding is that the virus itself, if it's dry, it will float up to 41 hours in the space before it goes to the ground. When it's floating, it's contaminating everyone in this space. And the virus diameter is really small. It's about half microns when it's dry. So if you look at the right side of the slide here, you see how big the virus should be to be able to infiltrate someone else's body. So it should be between 5 to 10 microns to go through your nose or your throat, 3 to 2 microns through your bronchi. It should be small. So when it's dry, it's half microns, it's easy to infiltrate your body. Now, if you have enough humidity in the space, the virus will come and catch these water droplets in the space that you don't really see and get inflated with this water. So now instead of floating for 41 hours, it's dropping on the ground after 6 seconds. And since it absorb the water in the space, now it inflates. It's not half microns anymore, it's about 100 microns, so it's really hard to infiltrate someone else's body. Based on these studies, it was shown that now the minimum relative humidity is not 30 anymore. It should be about 40, 45%. Maintaining at least 40, 45% will help a lot controlling the virus anytime there's a virus. And it's not just in direct contact, even if you have indirect contact. Let's say you're in a school, a hotel, a hospital, and someone is sick in room 101, well, the virus will go through the vent duct and come and affect another patient in 102 or 103. If it's humid enough, the virus will not have the time to float up to the ventilation duct and will stay in the same room. So based on these studies, there was a readout from the White House last October in 2022, which highlighted and showcased the importance of indoor air quality. And to make it very short, that's where he said the Biden administration has called on business and school leaders to take key steps to improve indoor air quality in their buildings as a key way to mitigate the spread of COVID-19. So, and I see it now in our industry, a lot of schools are starting to integrate humidification inside of them. So keep that in mind. It's really important to maintain a certain level of humidity. So now when we talk about humidification, you have 2 types of humidifiers. You have isothermal or adiabatic. So as you see on the psychrometric chart, isothermal, you're just injecting steam. So you're using an external source of energy to get your steam out. It's even gas, electric, or steam itself. Adiabatic, you're using the heat from the space itself to create the evaporation, and at the same time, you're cooling and humidifying at the same time. So in the next slides, I'll explain where adiabatic makes sense to be used and where isothermal makes sense to be used. So what do you have available on the market for both technologies? For the isothermal, you can have electrode humidifiers, electric resistive humidifiers, gas-fired humidifiers, steam-to-steam humidifiers, and for the pressurized steam, you can have direct steam humidifiers. On the adiabatic side, you have high pressure system, evaporative media, compressed air system, and ultrasonic. So what do you need to consider when you're designing a job? Okay, so how you can decide which product you use? Well, you need to know what's your application. Do you need precise humidification or not? Do you need to know what's your water quality? Is your water quality hard, soft? Are you using water treatment? Yes or no? That will affect what technologies you can use. You need to know what's the capacity. If you have big capacities, as you see on this chart, it will vary on what type of product you can use. Electric are limited to 300 pounds per hour. Yes, of course, you can use bunch of electric units to get to bigger capacity, but sometimes the building does not have enough amperage to take all this capacity. So based on also what's available as an energy source, if gas is not available, then it's not an option. And also you need to consider how you want to distribute your steam. What's really important in humidification, it's to know what type of water you're dealing with. So let's say you're designing a job somewhere in Ontario, you need to make sure that you know at least the hardness of the water where you're designing the job, because that can be uh, a big problem for your unit if the water is too hard. So when I talk about hardness, I'm talking about the calcium and magnesium inside your city water. There's always calcium, magnesium in the water. Depending in which area, you can have soft, moderate, hard, or very hard water. So soft and moderate, it's between 0 to 120 particle per minute. So if you want to calculate it as grain of hardness, that's how usually we talk in humidification per grain of hardness. So you take, let's say 120 ppm and you divide it by 17.1, you get your hardness. Usually water that's more than 6 or maximum 7 grain of hardness, we're starting to talk about hard water, and we need to start looking at options for the water treatment. So what type of water treatment you have available? You can have just a water softener. So you are replacing the calcium magnesium by salt, which is less harsh on scaling. You can have an RO system. So you have a reverse osmosis system. You have your RO membrane and you push pure water out of your system to your unit. Now, keep in mind, if you guys want to spec an RO system, you always need to have a water softener before the RO. Because if your water is hard, it will go and eat your RO membrane very quickly. You don't want that. So any RO system should be specified with a water treatment, with a water softener before the unit. So first technology that exists is the electric electrode humidifiers. So how electrode works? They work with conductivity. So as you see here, inside your plastic cylinder, you have electrodes immersed in water. So once you want to start the unit, you start filling up your unit, the water will start going up, and then it needs to drain, refill again, drain, refill again, until there's enough concentration of minerals inside your plastic cylinder. So this concentration of minerals will create a current. Depending on the capacity of the unit, once you reach the current that you need, you'll start getting steam out. So for this technology to work, you need to be using city water because you need conductivity. So you can't use RO or DI, that's pure water. And this technology is suitable for standard application, for comfort application, where you don't need precision, where you don't need to have tight controls, because this unit will always fluctuate plus minus 10% the whole time. So let's say in an office building where just you're putting some humidity for the comfort of the people, it's fine. No one will feel the difference as a human being between 30 or 40%. But you still need to keep in mind that it only operates with city water. So you need always to use the water available. So if your water is too hard, the problem with that is that you will scale up your electrodes very quickly, and then you need to change your plastic cylinders frequently. The second option you have it's electric resistive unit. So instead here of having a plastic white cylinder, disposable cylinders, you have a stainless steel evaporative chamber. And inside of it, you have heating elements. So you have heaters. Since you have heating element, you can use any type of water because you're not depending on the conductivity. You are heating your water as your element. So you can use city water, softened water, reverse osmosis, or DI. Now, if you have a precise application, let's say you're designing a lab or a pharmaceutical application or a place where you need precision, for you to be able to get precise control on the humidification side, you always need to use electric resistive units with SCR control. So by using SCR, you're modulating your unit the whole time. And very important, only for precision, you need to have an RO or DI before the unit. Now, if you want to use this unit for comfort application or any standard application and the water is fine, you don't need RO or DI. City water is great for this application. But if you want precision, you want RODI. Why is that? Because this unit, it will go into a full drain cycle every 4 to 6 hours, depends how you program it. So it can dilute the scale inside your tank if you're using city water, because it want to make sure that it does not build up a lot of scale. So every 4 to 6 hours, it will drain, refill with fresh water to try to minimize the scale building inside the tank. So during this process, during the draining and refilling cycle, you lose your set point. So if you want to be always precise, that plus minus 1%, you need to put an RO system before the unit. So now the unit don't have to drain because it's a pure water that's getting through it. So it will keep running the whole time. And that's how you can achieve precision in critical application. So what's the pros and cons for each unit? So if you take the resistive one, the advantage you have, it's a permanent cleanable chamber. So it does not cost you a lot on the maintenance side. It works with all type of water qualities. And as I said, it's very tight control. The downside of it, you need to clean the tank every year. Now, depending on the brand you're using, some brands are much easier to be cleaned than other brands, but it's still a maintenance point that you need to consider, that you need to clean your tank every year. If you look at the electrode units, the positive side of it is that you can change your plastic cylinders once it's filled off scale, so you don't have to do any cleaning. You just buy a new one and install it. The downside of it is that you're buying new ones every time, so on the maintenance side, it can get expensive. The control side, you don't have tight control on the unit, and you are quite limited with what the city water is offering. You can't use different type of water treatment. Plus, the plastic cylinder itself is not recyclable. So if someone cares about the environmental aspect, that's also an issue. So the second options you have is gas unit. What type of application will go gas? Any application that you need big capacities. Let's say you have a big warehouse or big office buildings where you need to inject humidity to every floor of the building, then gas can always be a good option. Why? Because gas can go up to bigger capacities, and usually in almost everywhere I cover, gas is cheaper than electricity. Even in your case in Ontario, I think only in Quebec we have electricity cheaper than gas, but most of the time gas is cheaper. But now keep in mind, everyone, and I believe in Ontario, you guys started doing it as well, trying to push out from gas to minimize the carbon footprint. So at some point, I don't know if gas will disappear. I don't believe so, because I don't believe we have enough electrical infrastructure to go electric on everything. But for now, gas, it's still an option. So as I said, gas, you can use it for any type of application, but again, not the precise application. So let's say you have a big pharmaceutical application where you need humidity in the whole space, but very tight humidification in one precise room. Then you use the gas unit for the big space, and you install an electric unit for this room to be able to do the tide control. You can't do tide control with gas neither, because the gas unit, even if it does modulate to 20%, you cannot keep it running down at 20% the whole time. So you can't get always tide control from a gas unit. So what's available in the market? You have two options on the market. You have a non-condensing gas unit or a condensing gas unit. So what's the difference between condensing and not condensing? Non-condensing, that means you only have one heat exchanger. So as you see here on the right side, you have a unit with a heat exchanger. Depending who's the manufacturer, you can have a coaxial heat exchanger or U-shaped heat exchanger. And then you boil your water, you get your steam out, your flue gas, which is usually about 270 Fahrenheit. You will take it through your chimney out to the space. You use a B-vent chimney. Now, if you look at that side, the left side, that's where you have the condensing gas unit. So the condensing gas unit, you have dual heat exchanger to be able to achieve condensing. So that's the unit, that's how the unit looks from the inside, and that's how it's designed. So you have a primary heat exchanger, and from the primary heat exchanger, you get your flue gas, and your flue gas, you pass it by a second heat exchanger. Now, depending on the brand you're using, you can even have your second heat exchanger divided in half. Half of it is air, half of it is water. Another brand will use a second heat exchanger filled all of water. And then by taking the flue gas from 270, passing it by second heat exchanger now, you are cooling down your flue gas to 140, 125, 140 Fahrenheit, which you are condensing. So you need a neutralizer to use this type of unit. So the big difference between non-condensing condensing is on the efficiency side. So in a condensing gas unit can go up to 90%. A non-condensing, if depending again on what brand you're using, there is very high efficient non-condensing gas unit that go from 85 to 87%, depending on modulation. So there's not a big difference on the efficiency side, but that's what exists on the market. You can even have condensing versus non-condensing. So what's the pros for a gas unit? You're getting clean steam out of it. You can go up to large capacities. Low energy cost because gas is cheaper, and efficiency wise you still get a good modulation, good efficiency. Now the difference between gas condensing and non-condensing is how complex is your system. Definitely by having a condensing gas unit, it's a little bit more complex because you have much more components to deal with inside your unit. The disadvantage of a gas unit, it takes more space than electric unit. You need to install flue installation, combustion. You need to have a chimney. You need to have gas in your building. It's not great for small application. Also, you have an option. Whoever you're using as a brand, everyone has an option to put the gas unit outdoor. So if you are limited in your space, or you don't have, or your run is very long from your unit to your chimney, then you can put your unit outdoors so you don't have to deal with a chimney. Because usually a gas unit, you don't want to run your pipes for the chimney more than 100 feet because it's not recommended. So you always need about 100 feet max. So if you are stuck in a place where you have a very long run, outdoor unit is always an option for you. And all the outdoor units can go to -40 Fahrenheit. So even in our area, it's fine. Another options you have in the market is steam to steam humidifiers. Where do you use the steam to steam? It's when you have an existing boiler already in your building. Mostly in hospitals, they have boilers. Some university districts or some other places where you already have a boiler, but usually the boilers have a lot of chemicals inside of them. So you don't want to push these chemicals directly to the space. So you take the steam from your boiler, you pass it through the steam heat exchanger, and you get clean steam out of it. Now, keep in mind, the pressure of the boiler usually is at 50 psi. This unit will work between 5 to 15 psi, so you need a PRV station. Sorry, before the unit to lower down your pressure. So once you get the steam, you can get it directly to your space. So where we use this application, mostly in hospitals or places where you don't want to push chemicals directly inside the building. Like if you have people working inside or some critical application, that's where you use steam to steam. The advantage of it, you always get clean steam. You can go up to very large capacities and you have a closed boiler loop. The disadvantage, but it's not a disadvantage, but for it to be able to be used, you need to have a central steam supply. It takes quite a space in a mechanical room, and you still need to do maintenance on cleaning the tank every year. Another option you can have is direct steam. So direct steam, again, you should have an existing boiler in your building, and then you decide that even if there's some chemicals in it, it's not that bad, we can push it directly to the space, then you can use direct steam application. So in this case, we're not using any generator to boil your steam, you are using the existing steam, so you pass it directly through your system. You can, and to go through the system, you need a float, you need a temperature sensor, you need a steam separator, a strainer, an actuated valve. So all these components, again, depends on which brand you're speccing. Even they will be shipped loose, and the guy on the control guy or the contractor should connect them all together to the unit, or they can be shipped with a controller that will manage all these components. So this green controller will go and read the temperature, read the humidity, and modulate your valve depending on the capacity needed. So for direct steam, you have two options. Even you go with multi-tubes, like this one here. So you have an empty header where you connect your steam, then the steam goes up, and then condensation goes back down. Or you can use the jacketed tube. So jacketed tubes, you have the grid, and then you have another layer of stainless steel tubes, which they are running steam to insulate the steam. So you kind of keeping your steam warm with extra steam so you don't condense. The downside of this technology is it's not very energy efficient because you are using a lot of steam to heat the steam. So you're using the steam as an insulation, which is very expensive to get steam from water to steam. So it's not the best, but we still see it a lot in the market because it's a cheap option. It's not that expensive as a first cost. It's easy to be installed, so we still see them a lot. The downside of direct steam is that you're pushing chemicals directly in the space if the boilers has a lot of chemicals inside of it. Okay, so now we spoke about isothermal unit, which I said, you need an external source of energy to get your steam out. The second option is adiabatic, where you use the heat from the space itself to create the evaporation process and get your air to be cooled and humidified. On the market, you have mainly 4 different options. The first option, it's the high pressure system. So a high pressure system, how does it work? You have 1,000 psi pump, pumping water all the time through high pressure hoses, and it goes through these nozzles here. And at the end of the nozzle, as you can see, there's small holes. So when the pressure water goes through these holes, it will break into droplets, get absorbed by the air, so it's humidified and cooled. Now, to be able to use this technology, you always need to have an RO or DI water before the unit for mainly 2 reasons. First, definitely you don't want any scale to clog your holes. And second, you don't want to spray scaling and white powder on wherever you are installing the unit in. So never install a high pressure system without RO or DI. Now you can have these nozzles, or you can have kind of a fan nozzle, like have different nozzles on a circular configuration, and you shoot steam out of it. You have different type of nozzles, and this type of unit, you can install it even in the duct or the air handling unit, or you can install it directly in the space. Ideally, I love these units to be installed in the space because you don't have to worry about wetting your duct or wetting your air handling unit. Because if these units are installed in a duct or air handling unit, you need a decent amount of space before you can have something else, at least 4 to 5 feet. So now if they are in the space, you don't have to add all this extra length to your system, but you just want to make sure that you have enough high ceiling so all the absorption happen before it hits the ground. So where we see this application, you can have this application mostly in printing industry, like where you have a lot of printers printing at the same time. So even in winter, you need to cool this area because there's a lot of heat generated from the printers. And as you all know, you need a certain level of humidity for the papers. So shooting the humidity inside this space, it's ideal. So you're cooling and humidifying at the same time. Some application also in arenas, you want, to cool down the arena, can be a good application. Now, what's the advantage of it? It's very low energy because you are just using the pump, which maybe draw 10, 15 amp. You're having free cooling, and you can go up to very large capacities. And you can have it in duct or in space, both options. But as I said, I prefer in space. And if you put it in duct, you don't have a lot of pressure drop added, so which is good. And you can have multi-zoning control with this unit. So one unit you can control up to 4 zones or 6 stages, depending if you want to zone for different zoning, or one big space, but you want to stage it down. The disadvantage, as I said, long absorption distance. If it's installed in a duct or a handling unit, you always need water treatment before it. And if you are using it not for the right application, if you, let's say, you want to reheat what you cooled down, it's a disadvantage because you kind of investing more energy now to reheat what you cooled down. And if you install it inside an air handling unit, ideally you want a mist eliminator after it, just to make sure that it's not condensing. The second options you have is the compressed air nozzles. It's the same principle as the high pressure, but instead of having a 1000 psi pump, you have a compressor of air, compressed air that will push from one side, the water connection from the other side, get your steam out. The same type of application as I mentioned on the first one, but people don't buy this technology anymore, mainly for one reason, is that the compressor itself costs a lot of money, of energy. Like running it in compressed air is not energy friendly at all. So people try to push back from this technology, but it exists. A third technology you have is the ultrasonic humidifiers. So ultrasonic, how does it work? You have a piezoelectric transducer. It's kind of like a disc that's immersed in water, and it does, it takes the electricity and it will change it into high frequency vibration. And when these discs start to vibrate, it will create kind of waves of compression and depression inside your water until the water start to break out and get the steam out. So what's good about ultrasonic is, like, they are small in size, they don't use much of energy, and again you get the free cooling aspect of it. The downside of it is that the initial cost is usually expensive, and the service life of the unit that does not last much, especially the discs. They need to be changed frequently, and the discs themselves are very expensive, and it's limited in capacity. So these units, you can use them for small application. Let's say you want 20 pounds, 30 pounds in a data center, or some places where you don't need a lot of capacity. it may be a good option. If you want big capacities, you cannot achieve big capacities with ultrasonic. The fourth option that's available is the wetted media option. It's kind of a swamp cooler, actually. It's nothing sophisticated. You have a fiberglass media, and you build your fiberglass media with a frame inside your duct or a handling unit, depending on the capacity, on the dimension of your duct air handling unit. And then you have water running through this media. So when the air blows through the media, it will get cooled and humidified. Now, you can even have the option to always run fresh water and take all the water, dump it to the drain, or you can have a recirculation pump. So you take part of the water, you pump it back through your media. Now, if you want to pump your water through the media, you have a couple options to filter down the water. You can pass it through a filter or through UV lights and use it back again. So where do we see this application? Again, in places where you need to cool at the same time. But the downside of it, this unit, you can't have it in the space. This configuration, you can't have it in the space. So you need to have it in a duct or a handling unit. So the downside, you are adding a lot of pressure inside your duct or a handling unit. So let's say if it's a clean, if it's a new unit, you'll add about maybe 0.2 inch. And when it starts to get dusty, the fiberglass, it will add about 0.5 pressure drop, which you need to compensate back on the fan size of your unit. The fiberglass media itself, you can use it with any type of water. But if you're using RO water, it's better because the fiberglass will last you about 5 years. If you're using your city water, depends how hard the water is, should last you about 2 to 3 years before changing the fiberglass media. But you can use it with any type of water. And the good side also is that you don't need to worry about absorption distance after the unit, because as soon as the water passes the media, it's already absorbed, so you don't need to care about absorption. Last option on the adiabatic side, not every company has this option, but it is available on the market. It's the same principle as evaporative media, but with a built-in ECM fan. So now instead of having it in the duct or air handling unit, you can have it in the space as well. Where do we see this application? Most of the application I've seen with this unit up to now is in data centers, but you can still have it in warehouse that you want to just cool your warehouse, so you can have it hanged from the ceiling or installed on the floor and blowing, cooling inside the warehouse. But ideally, it's a great application for data centers, because data centers, if you look on how they design usually data center, you have always a cold aisle and a hot aisle coming from the heat of the servers. So what this unit made, you install it usually up on the hot aisle side. So all the heat coming from the hot aisle will go through your unit, push through the media to get cooled, humidified, and then you can duct it with a plenum back to your crack unit. So now you're supplying your crack unit with much cooler and humidified air. So the crack unit don't need to work that much to get your cooling temperature down. So you can downside your crack unit. So now you're saving money on the crack unit, on energy, because you're having free cooling on this side. And why data center is a good application? Because it's the best environment for this type of adiabatic unit. Because for this unit to give you the best efficiency, you need dry and warm air. And that's what you're getting from data centers. It's a dry and warm, it passes through the media, it gets cooled and humidified. So on the dispersion methods, so what I showed you up for now, it's even the isothermal where you boil your steam or the adiabatic. But on the dispersion side, you have also two options. Even you get a blower pack, so you blow directly in the space, or you put it in a duct or air handling unit. It's really rare that I see big application with blower packs. Some of them, yes, you will see them here and there, but mostly people will use duct or air handling unit. The advantage of having a blower pack is that you don't need any plumbing. It's directly on the unit. The disadvantage of it is it's a poor distribution. Like you can't have your steam going everywhere if you have a big space and you're just blowing from the blower pack, and it's limited in capacity. You can't go very high on capacities, and it's very noisy. So let's say you want to put that in an office building, in a room where people are working, it's not the best because it does make a lot of noise. So your best option is even to put it in the duct or air handling units. So when you want to specify a grid, I always recommend you guys to spec an insulated grid. Because remember, at first, when we start talking about the condensing gas unit versus non-condensing, and I said there's only 4 or 5% efficiency between condensing and non-condensing, it's not where the real saving is. The real saving is in here, and if you insulate your grids or not. Because by insulating your grids, depending whose manufacturer you're using, you can go as low as 85% saving on condensation loss, which is a huge. Because when you have, let's say you have a big grid like this one inside your duct or in handling unit, and you have a bunch of these distributors, you have steam running through them at 212 Fahrenheit, and your airstream is at 55 Fahrenheit. So when the cold air hit these grids, you'll start condensing. All this condensation, that's money that you paid for to get your water from the water level to steam level, and then just cool it down, take it to the drain. So by insulating these grids, you can save as much as 85% condensation. Now, there's different type of insulation. You can even have your grid insulated with a PVDF insulation and then encapsulated with stainless steel. You can have it 2 layers of stainless steel, but no PVDF inside of it, just an air gap, or you can just have it PVDF with no stainless steel. So there's different type, depending which manufacturer you choose, you'll get a better on the efficiency or a little bit less, but anyhow, whoever you spec, if you put their insulation, you are kind of saving money anyway. So that's a very quick example that showcase what I'm talking about here, and I'll go through it very quickly. So if let's say you have a 20,000 CFM unit, 50% makeup air, that's your outdoor conditions. Based on these calculation, I know I need 240-pound unit. So, and let's say I have 30 inch of absorption distance. So for 30 inch, to be able to give you this capacity, I need to give you 6 tubes with the grid. By having 6 tubes, I'm condensing 16 pounds per hour. Now, if I take the same example and I put an insulated grid, but it's still the same 6 tubes, but now instead of condensing 16 pounds per hour, I'm condensing only 2.4 pounds per hour. And instead of adding 0.76 Fahrenheit to your heat gain, you're adding only 0.11 Fahrenheit to your heat gain. So insulating the grid, it's really important. And also what's important to keep in mind, the absorption distance. The absorption distance, that's the distance you need as soon as you leave your grid until all the steam is absorbed before you hit something else. Now, if you have 30-inch available, spec 30-inch. Don't spec 6 inches or 10 inches just to make sure you're safe, because by shortening the absorption distance, the only way for us or anyone in the market to give you a shorter absorption distance, we need to add more tubes. So let's say in this example, if you told me you have 6 inches instead of 30, for me to be able to give you the same capacity, I need to give you 31 tube now instead of 6 tubes. So as a first cost, your customer is paying much more money. As a running cost, he's losing much more on energy because now he's condensing 80 pounds per hour instead of 16. And he's adding 3.5 Fahrenheit of heat gain. So that's huge. So keep that in mind. It's important. Also, let's say you're designing a job and you have this layout, which is typical layout in an HVAC system. And you have the options to put your grid in A, B, C, or D. Since I'm not seeing you guys, it's via Teams, I'll answer the question. Which one is the worst that you never want to install in? It's D. You never want to put your grid before heating your air, because as I said at the beginning, cold air cannot retain water. So if you put your humidification before your heating coil, you're not doing any humidification. So never put it before a heating coil. Ideally, you always want to put it after the heating, after the cooling. So A or C, both options are good. A, it's a little bit better because the flow of the air is more laminate. In C, it's a little bit more turbulent, but it's not a big deal. As soon as you respect your absorption distance, A or C, you're fine. Now, if you're really stuck and you don't have a choice to put it in B, then you need to make sure you interlock your cooling and your humidification. So both of them don't run at the same time, because you want to make sure you're not running your cooling coil while you're humidifying, because you will be dehumidifying on your cooling coil. So keep that in mind. And always keep in mind that you need safeties when you're designing a job. So you always need to have a high limit and airflow switch. Most of the time you want to install them at the end of your run. So the airflow switch will measure the CFM. If there's no more CFM, it will shut down your unit. Your high limit will modulate your unit to make sure you don't get to your saturation point and start the dancing. So that's mainly for me. The control side, I already spoke about it. So now it's for you guys if you have any question.
Thanks, Ronnie. Yeah, so if anybody has any questions, feel free to put them in the chat. And if you don't have one right now, but you come up with one later, Odell is the Neptronic rep across Southwest Ontario. So that includes our London, Burlington, and Waterloo office, as well as in Ottawa. You can reach out to your sales rep at Odell, and we can either get you in touch with Ronnie and Neptronic, or we can help you out on our side. Just so you know, this will be recorded. This was recorded, rather, so it'll be available to you. Sarah will send out the link, and it'll also be posted on our website. So if you have any coworkers that weren't able to make it, or if you just want to review it again, you can find it there, and you'll get a link in our follow-up email as well. So just want to say thanks, Ronnie, for taking the time to do this today. I know that I definitely learned something. Hopefully everyone else did as well. And yeah, just a reminder to reach out to us if you have any questions about anything that we went over today, or if you think that there was anything that we omitted that you'd like to learn more about, let us know.
Thank you, Cam.
Thanks for joining, everybody.